the information that a grower will get will be so powerful and also informative for them to make good decisions about growing their cane. And that's ultimately what this whole project is about.
Hello and welcome to Cane Matters. I'm your host, Sonia Campbell, and in this episode, we're discussing an SRA research project that is progressing technology to quantify Ratoon Stunting Disease, or RSD, in every rake of cane that enters a mill. RSD is a serious bacterial disease of sugarcane that lives in the vascular system of a cane plant, restricting the plant's ability to carry water, leading to lower yields. However, up until now, it's been a difficult disease to diagnose due to the lack of its visible symptoms in a plant. Research that is currently being undertaken by SRA aims to change that, using near-infrared technology to detect the potential presence of RSD in cane processed through each mill, and backing up these qualifications with molecular testing to confirm the RSD pathogen. The project is being led by Lead Field Pathologist Dr. Seona Casonato, who joins me today to discuss what could become a game changer in increasing industry's understanding of the true distribution of this disease. Welcome, Seona.
Thanks, Sonia.
So I'll get you to start by painting a picture. Just how important is this disease to industry?
This disease is very important to the industry. It's spread through practices that are utilised currently in the industry. It can be spread through harvesters, through planters. And it's important to note that this disease, the RSD, is present in every single growing region within Australia. As you mentioned before, you cannot see it with visual symptoms, and therefore it often goes undetected. So what this project will enable growers to do is have information and the knowledge that we're going to give them to indicate in what rake they have this disease is a very powerful tool for them. And this will enable us to provide information about how to manage this disease on a grower's property and within regions.
So up until now, how have we tested for the disease?
Previously, how we tested for it was using a microscopic visualisation. We'd cut a slice off a piece of cane, look down the microscope and try and see the pathogen. Then we've moved on and developed an ELISA, which is using a technique to determine whether it's present or absent, but this isn't very sensitive. Then as technology improved, they've utilised polymerase chain reaction, PCR. This is a very sensitive molecular tool, but what it can only do is say whether it's present or absent. So we've moved on the next step and we're using quantitative PCR, and what that does, it'll be able to tell you how much of the bacterium that you have in your particular sample.
This project is bringing in the use of NIR technology. Now, NIR is near-infrared technology. It's often used to detect different substances and different qualities in cane. How is this technology being applied in this current project to detect RSD?
The NIR can't actually detect whether the actual bacterium, the propagule, but what it does is it looks at those changes that could be attributed to RSD, utilising the molecular tool, which we're utilising qPCR, that will tell us whether that particular rake that is then harvested and then sent to the mill, and from that first crush we will get the mill juice. It will tell us whether that rake has the bacterium in it. And then we will correlate those readings with the NIR. There is no way we can do every single rake that goes through the mill because it's too expensive. Yes, it's highly accurate, but we will utilise a subsample of all of the rakes that go through the mill to correlate with the NIR readings and see if we can get some idea using NIR whether the difference in the readings is attributable to RSD presence or not.
So you're using the molecular data to validate the readings of your NIR, and you're using that to make calibrations for the NIR system.
Yes, with NIR, the most important thing is it's read after read, and the most important thing is data. The more data that NIR algorithms have, the more accurate it is, and the better the calibration between what we get with a positive or a negative for RSD bacterium detection to what the read is with NIR. So therefore, we can be more confident with more data. We will never be able to run an NIR without this molecular calibration because that keeps everything in check. And that in itself is really good information. But what I think is more important for a grower is understanding how much. It's all about how much. Do I have it really bad or do I have just a little bit? Now, utilising qPCR, we'll be able to get those results to see whether we've got a very high load of bacterium, and we'll be able to look at those reads with the NIR and link them together, basically. That's what we're doing. And so therefore, the NIR should be able to say, we've got a lot of potential RSD here, or we've got less. And that is very powerful information for a grower in able to go forward in managing their crop.
So you're really taking the guesswork out of the distribution of the disease across each milling district.
Yes, and I think that really helps in particular at around harvest time, because we're seeing where are the hotspots potentially of RSD, and therefore that means that you can work out about what you're going to do and where you're going to harvest at a particular time. All of this is information that will help the grower to manage and, most importantly, contain RSD. Containment, if you have it on your property, is really important. You might have it and it's not the end of the world, but you want to contain it. And so having this information with this project whereby we're using NIR and we're using qPCR will give growers that. Ultimately, what we would like is that the NIR can be utilised in real time for growers to see what's happening on their property.
And that's where it's so important with this project, because currently, how does a grower discover whether or not they've got RSD in their paddocks?
Well, in most cases, people are of the belief that they potentially have not got it, whereas I would like to have growers thinking, there's a potential that I have got it. So therefore, you are always being really vigilant in trying to contain it. But how do they actually find out at the moment? They will get the services of productivity boards that will collect samples, and at the most likely they will use what's called a leaf sheath biopsy, where we punch holes in the leaf, or we use xylem, where we're sucking the xylem out of the cane, which is the juice. This is collected and then sent down to the Iris lab, the SRA Iris lab in Brisbane, and it is run through using qPCR, and you'll get a result back to say whether it is positive for RSD presence or not. Now, that does not mean that it is negative. What it means is it is not detected. And that is because of the sampling regime of when you go out into a paddock and you do samples, you are collecting from 16 sticks, and you can have in one paddock over 80,000. So it is a numbers game. And this is where NIR in the mill is very useful, because it will give you a broad view of what's happening in your paddock. Do you have it or don't you have it? We've collected that juice from one rake, which is typically in one block of cane, and we can say whether you do have it in that block or not.
And that's where the power is with this project, is you're going to know not only whether or not you have it, but you know how severe you have it.
Yeah, I think this is a very, very powerful piece of information for growers, because it enables you to make educated choices about how you're going to manage RSD on your particular property in that particular block. If, for instance, that you have RSD at extremely high levels, you would think, okay, well, maybe the best decision here is I can't get another Ratoon out of it. It's not going to be very productive. So therefore, you would replant. You would remove that crop and replant potentially. Obviously, you would talk with the professionals and make a educated decision. On the other hand, if you found out from this mill juice project, which is the use of both the NIR and the qPCR, then you can say if you have very low levels, then I have to be very wary. I have to make sure that I contain the in and out of that particular block so that I don't spread it. But potentially I can get many more Ratoons out of it, because the level of the bacterium in that particular paddock is very low and may not be affecting your productivity.
SRA has solid guidelines for RSD management. What are the main things that growers can do to manage their RSD with this basic knowledge they've got at the moment of whether or not it exists on their farm or not?
So one of the best ways to maintain an RSD or relatively RSD-free farm is to make sure that you source your plant cane from productivity services that have approved certified seed cane that they will distribute to growers within that region. That's fundamentally an important step in the establishment of your crop. Just so that growers know, these distribution cane from productivity services is rigorously tested for RSD prior to release. So therefore, you can be rest assured that it should be clean or virtually clean RSD. What I want to make sure is nothing can be guaranteed that it's 100% clean. But this would be the best quality cane that you can get to establish your crop on the property. Upon establishment of your cane on your property, harvesting is the next critical stage in the movement and potential contamination of your crop due to the harvesting machine. So fundamentally, we recommend the most important thing to do is ensure that you have a sterilised harvester, and that if you as a grower are unsure about whether that harvester is clean, you have the right to ask that harvester to clean down that harvester before harvesting your cane, because the harvesters are known to spread this bacterium. The other thing is, at planting time, people tend to neglect that this is a potential avenue for RSD spread. So ensure your planter is clean. Sterilisation is key here. It is much more effective to sterilise both planters and harvesters prior to dealing with your cane to ensure that you have the cleanest machinery possible to mitigate any spread of the RSD. Another aspect of management is not to do a replant directly into the same block. What you should do for multiple reasons is fallow, at least for one whole cycle, fallow that piece of land prior to replanting. Now, what is crucial, it doesn't matter whether you do bare fallow, whether you use alternate crops, which have other benefits, but make sure there is no cane present because that can be a host for RSD. So it's really critical to make sure that it is sugarcane free.
Last season, molecular data was collected from 4 milling areas: South Johnston, Tully, Bundaberg and Isis. I understand this data will still need to be scrutinised further, but what were the preliminary results from all 4 mills in the rakes that were tested?
What happened with all 4 of these milling areas is we got the presence of RSD that was between 20 and 30%. Now, it's important to note that it ebbs and flows within each of the regions over the harvesting season. So it doesn't mean that you're always getting 30% of all of the rakes that are all infected every single week. What it means is sometimes we might have had no RSD within one harvesting week. And that's all dependent on the crop, the age of it, whether it's at the start of the harvesting season or at the end. It also depends on where you're harvesting and how those particular blocks are managed. So it's really important to also note, in very well managed blocks of cane, you will have good production, not only because they may have less RSD, but because they mitigate other issues that can contribute to lower production. So the preliminary results are interesting. The amount, let's say the level does vary between the different regions, with some regions and at some times may have very high levels and others may have very low. But it's preliminary data, and why I say it's preliminary is, for instance, at Tully, we've got 30 samples from every single week of the harvest, and that is not representative of the entire harvest season. In actual fact, they have over 5,000 samples, and Tully Cane Productivity Services Limited here in the Tully Mill region have collected a mildew sample from every single rake within this area. This is over 5,000 samples, and these samples have been sent down to IRIS in Brisbane, and the results, some of them have come through, and there will be more that will be coming through, and that will enable us to get a really good picture about what's happening in this area. But the NIR and the qPCR project actually utilises just 30 of those samples each week to try and calibrate what the NIR reads were. So I think what it highlights here is, with so many samples, over 5,000 samples, you can't quickly process them. And this is the beauty of using NIR, because it's quick. It's quick.
We just talked about that 20 to 30%, which you did clarify. So you're talking about a potential up to a third of cane coming through into mills at certain stages with RSD infection. But as you said, this is preliminary data, but you believe yield losses in this cane is not solely attributable to RSD infection alone. How do you determine that, and why was it not surprising to you that a yield loss with cane with RSD is not contributed solely to RSD?
I think I wasn't surprised, Sonia, because, as you said, yes, it can be yield loss and RSD can contribute to it, but it is not the sole and only factor. It's other factors of management at the property whereby you need to be managing your weeds. You need to be managing other diseases that are present. You need to manage your pests, your insects. You need to look at when you've planted, when have you actually harvested, because all of these have a flow-on effect with your subsequent production and ultimately your yield. So all of these things together can contribute to yield loss, and it cannot be solely attributable to RSD alone.
The project, though, as you've said, will still assist in telling a grower if they do have low or high RSD infection, and it will help the grower in their overall RSD management.
Absolutely. I think the information that a grower will get will be so powerful and also informative for them to make good decisions about growing their cane. And that's ultimately what this whole project is about. It's not about saying, goodness, you've got RSD, you've got a big problem. Okay, what it is, it's information for us to know, yes, that grower has RSD in that particular block. How am I going to manage it? How am I going to mitigate the spread? And that's what it's about. And then understanding, if I have this particular bacterium, what am I going to do to get as many ratoons as possible? And it's all about ultimately the cost to benefit ratio for a grower. So production is key for any grower to be able to sustain their business, and knowing whether you have a low or a high amount of RSD on your property is very informative. What's most important is how to manage the spread, or shall I say, to stop the spread of RSD. That's the key here. I think as an industry, we're really aware of RSD and we're doing the best we can to try and contain this bacterium. And having this information is so powerful for a grower to say, okay, I have it in this block. What am I going to do?
What is the time frame for the project, and when can we expect for this NIR system to be in place in mills?
Sonia, this particular project goes to 2028. At the moment, what we're trying to do is see in the mills that do utilise NIR whether we can potentially implement it. We hope by 2028 that the calibration with the molecular work and the NIR algorithm are accurate and, most importantly, are reliable in indicating where RSD is within a particular farm, so that we put this piece of technology out there, and we know that it can be utilised and it's going to work. That's the most important thing. We really hope that everything goes according to plan, and we're doing our utmost to make sure that it is as accurate as it possibly can be. We want to make sure that we put a robust system out there so that we can provide the growers with the best information that we possibly can about RSD throughout a whole area, throughout a milling region, so that they can make sound decisions. So, yes, we're ultimately hoping that we get it implemented, the NIR, and it's calibrated with the molecular work, and everything's up and running by 2028.
Not all mills use NIR technology. What about those mills that don't have NIR technology installed in their systems?
What we're doing as part of this project, Sonia, is actually saying to these mills that don't implement NIR as part of their system, look, it's important for you to still know about RSD out there in your region. So we can take a small subsample of mill juice and do the qPCR, the molecular work on it, so that it's indicative of what is potentially occurring out there in the field. And we are doing that this coming season with some of the mills that don't utilise NIR. And I think that also gives the growers an idea of what's happening out in their region. Whereas for the mills that utilise NIR, what it's going to do is make that NIR algorithm much more stronger by having this weekly validation of the system to indicate by qPCR what level of RSD we have, and then to calibrate that back to the NIR reads. So we hope that by 2028, we're able to say, yes, everything's worked. We'll be able to roll out this technology into mills whereby they use NIR. But we won't be doing that until we are sure it is accurate and reliable. The most important thing is to ensure that the results that we obtain using both the NIR and the qPCR is useful information that can inform growers to make good decisions. And it will only be when we get this reliability and accuracy that this will be implemented.
Well, thank you, Seona, for providing your insights today, and thank you to our listeners. SRA will continue to keep industry updated on the project's progress and outcomes. SRA would like to acknowledge that this SRA-funded project is an extension of a previous 3-year project funded by the Department of Primary Industries and Sugar Research Australia.